All right, today we're going to talk about the internet and the protocols used on the internet. We all probably have an idea what the internet is at this point. We go to a web browser and type some stuff in, and we get some stuff back. Basically, the internet is really just a big connection of computers, a giant global network of connected computers that somebody decides to stick on the internet, and the resources you're accessing on the internet is just some computer out there that somebody has enabled a service on and allowed you to access. The most prevalent service we access on the internet is a web server, but there are other services out there, such as mail services. We need to get DNS services, other file transfer services, remote connection services such as SSH and Telnet. So pretty much any network service can work on the internet, but like I said, the most prevalent service people think of when they think about the internet is the World Wide Web. So how does that work, and why is that important to us? It's important to us because as network technicians, we may be called upon to troubleshoot why some web page is not working, and we need to be able to understand what really happens so we can figure out where it is breaking and whose problem it is. Hopefully it's on the other side's problem, so we can say, hey, that's the web server's problem and we don't have to work anymore. But we need to be able to say that definitively and with some authority. So how does it work? Basically, the client uses the web browser to connect to a web server. The client requests a web page, and the server returns the page. Is it really that simple? No, it's really not that simple. A lot of things happen when you make a web request. This is going to be a very simplified version of it, but essentially you type in a URL, a uniform resource locator, that normally is just www.domainname.com is what we type in a lot of time, but a full URL has the protocol which your web browser will stick HTTP on the front of the URL you put in there if you do not specify, since that's the default protocol web browsers try. Then you have the domain name. In this example, we have www.richesthebest.com. You can have an optional port number. By default, the web port for unsecured traffic is 80. The web port for secure traffic is 443. Those are the default ports. But if you need to connect to a different port, you can specify that after a colon. In this example, we're connecting to TCP port 8080. And then after that, you have the path. The path is the location of the file that you want to retrieve. If you just put in the domain name, then it looks for the web server software can be configured to look for specific file names. And usually they look for something like index.html or index.php or index. Some other nonsense. So that's the beginning of it, but it's still not complete. We put in a domain name, but in order for our computer to be able to retrieve that page, we need a IP address. So the domain name gets translated into an IP address. So we get back the IP address, and then our web browser asks TCP to initiate a connection so that we can connect to the web server, and TCP has to ask IP to create a datagram to send that TCP connection request over to the other server, and then that gets passed down to Ethernet to be delivered locally across all the different hops till it gets to the other server. So as you can see, we're finally learning about the top layer protocols, application layer protocols, but we still need to know everything about all the stuff we've already learned up until this point, because if we have an issue connecting to a web server, the problem could be anywhere in that stack that we send the traffic down. So at this point, we're going to start talking about the hypertext transfer protocol. It's the main protocol we use to retrieve web pages from servers. There's three versions you might run into. The original version was 1.0. Updated version, the most prevalent version you might run into nowadays, is 1.1. And the newest version, 2.0, was only made official, I think, in 2015, the summer of 2015. So it's the newest version. Why are there new versions? Well, after a while, people realize the old version doesn't work all that great, or it can be made to work more efficiently, so they update it, and then that's why we get new versions. The protocol defines the structure of the messages to be exchanged between the client and the server. It uses TCP. That makes sense because we need to get our data reliably. How beneficial is it for us to download a web page with a bunch of pictures if we only get half of a picture? We need all the data, so TCP makes sense. So we talked about web pages. Some different types of web pages you might run into is a static web page, dynamic, or an active. A static page is the basically a page that doesn't change until somebody goes in and changes the code that's stored on the server. Static pages are usually written in HTML. If you access a static page over and over again, you're going to get the exact same content until somebody else goes and changes it. A dynamic page is generated on the server when the file is accessed. In this case, say you want to do something like show the current date and time when somebody goes to the page. So you have some code inside your file that gets accessed that runs a program or a script to get the date, and then it outputs that date onto the page. So you click on the link for the page, the script runs on the web server, and then the text gets put into the web page that comes back and shows you the current date. The date doesn't continuously get updated. It gets updated once when the page is accessed, and then it stays set on the page in your browser. If you wanted the date to be continuously updated, you would need an active page. An active page loads code in the browser that is executed locally and allows you to continuously update content. Java and JavaScript are good examples for that. In a few weeks, we will use a GUI tool to manage some firewalls that run Java. That's an example of some active code that we'll get to look at in a few weeks. So what's the difference between active and dynamic? Dynamic, the code runs on the server. This is the main difference. The code runs on the server and outputs text that gets generated when the file is accessed. An active page, the code runs locally, and the browser displays the changing content based on the code that's running. So HTML, I mentioned HTML earlier. You may have seen HTML somewhere. It's a code that the browser interprets. A couple of main things that it tells the browser. It tells it how the page should look. There's tags in the HTML that says, hey, this should be bold, this should be tabbed over, there should be a break here. And then the HTML normally consists of text for the page, which isn't on my slide, and also tells the browser which other files to download. So if you look at a typical web page, the client will ask for the HTML page, the server will send it back, and then the page will get that HTML and it will interpret it. If you look at this sample HTML I have listed here, basically this is the first file that came back from the request. There's HTML tags in there, there's a title, there's a body, and then it tells the browser, hey, I need these 3 pictures. So the browser now needs to retrieve those 3 pictures, picture 1, picture 2, and picture 3. So basically, that says the same thing I just said. The main page comes down, and then it needs to get the 3 files. In this case, the 3 files are pictures, but they can be scripts or include files and other things. How does the browser retrieve those other pages? Well, it depends. It's going to make another HTTP request to say, hey, web server, give me that page. And give me that picture, and that picture will come down. But then we have this idea of persistent versus non-persistent connections. In HTTP 1.0, it specified you should use non-persistent connections. So what that means is it would establish a TCP session to get the initial page, and it would terminate that session with a fin. And it would establish a new TCP session to get picture 1, and it would terminate that session with a fin. And then it would establish a new TCP session to get picture 2, etc., picture 3. HTTP 1.1 allowed for persistent connections. That would allow us to reuse a TCP connection. So we would open a TCP connection, and then we would get multiple files across that one connection and eliminate the overhead of trying to open a new session every time we needed to get a new file. How it actually works is controlled by the browser maker. We'll look at this in the lab, and there's actually a podcast that goes over looking at the HTTP connections. It really opens multiple concurrent connections. So it uses persistent connections, but after it gets the first file, it normally opens some number of additional TCP sessions so that it can download those other files concurrently. So there's 2 main message formats with HTTP. We're going to look at a request and a response. If we look at this capture from Wireshark, this is a request message. You see that second line under the hypertext transfer protocol. That's the request line. Get /CNT220 HTTP 1.1. So that line after that tells the host. So that first line, the get is the request method, the CNT 220 is the path, and the HTTP 1.1 is the protocol, and then the host is www.rich.org. So those are the four things we said was in the URL. So those appear at the top of the HTTP request. And then we have some number of headers that aren't really all that important to us right now, but you can just be aware that headers exist, header lines exist, and the servers and clients use them for different reasons. We will talk about one particular reason they use those in a couple minutes. Here's the response from the server: HTTP/1.1 200 OK. So that's the status code that comes back from the server. There are also a bunch of header lines that come back from the server, a date, the server type, and some other stuff. Status codes are useful. 200 OK means everything was fine. They're useful for telling the client what the state of the request is. I mentioned request methods. If you just go to a web page and type in the address in the browser, that's going to be a GET request. Basically, it tries to get the file. A HEAD request will show you the beginning of a file. It can be useful sometimes if you just want to see if the file has changed. A POST request allows you to send data to the server that the server can act upon. A PUT lets you send data. Delete lets you delete things. Trace, connect, and options. Those are some extra methods that aren't really used that often. I take that back. Connect is used if you want to switch to HTTPS, but some of those others aren't really used that often. We have status codes that define what happened with the request. There are 5 different categories of those guys. 100 status codes are informational. 200 status codes mean they were successful. 300 status codes are redirection. 400 status codes are client error, and 500 status codes are server error. You've probably seen 404 not found is probably the most common error you might see when you browse to a web page. It's probably the one most people see the most. But we'll look at some of these status codes in the lab and even a little later on in these slides. So one interesting thing about browsers and servers is lots of times web pages don't change very much. So we could potentially be sending the same files back and forth over and over and over again. Imagine if you go to your bank website, their logo is probably not going to change very often. So once you have a copy of the logo, you don't necessarily need to download that copy of the logo again. So browser caching allows your browser to download a file only if it has changed since the last time you downloaded it. So basically how that works is in your request, here's an example of a HTTP request. It's trying to get a file called underachievementdemotivator.jpg, and if you look about halfway down, maybe 3/5 of the way down, there's a header that says if modified since Thursday 01 November 2012. Basically it's telling the server, hey, send me that picture if it's changed since this date. And if that picture has not changed, then the server will not send it. So where does that if modified since time come from? Is that the time when the the client accessed the server? No, that's actually the time when the file was saved, and we got that from the status message when the file was delivered. If we look at this HTTP response header, we can see there's a last modified header field in there that says, hey, this file was last modified Thursday 01 November 2012 at 3:23:53 GMT. So when you download a file, the server tells you when it was last modified, so you can store that information in the cache along with the file. So then when you send a new request, you say, hey, if it has been modified since November 1st, 2012, send me the new copy. If it has not been modified, the server will respond with a 304 not modified. So instead of you spending 2 megabytes downloading a file you've already gotten 12 times, the server can simply tell you, hey, you've already gotten that file. That's an important thing for us to understand from a troubleshooting perspective, because sometimes you may be looking at things and expecting certain things to occur, like you request a web page and you expect files to come down, but no files come down, and you think things might be broken because you don't really know what's going on. Well, no, it's working exactly as expected. A way you can force it to download is you can clear your browser cache, and then the files will be gone, so it'll force it to download the file again. Or I'm pretty sure if you do something like hold down the shift key when you hit the reload button, then it will force it to download the content again. But don't hold me to that. I'm only like 83.7% certain that works. So that's a little bit how browser caching works. Next thing we're going to talk about is HTTPS. The HTTP protocol does not specify anything for security. It is basically a protocol for transferring files, hypertext, I guess you could say. It is in the clear. So if you're looking at traffic, which we will do in the Analyzing HTTP podcast, you can see what's going across. That's not good if you're doing banking or sending email or doing anything else you want to be secure. So in order to add security to the HTTP protocol, we do HTTP over SSL. That uses Secure Sockets Layer, was what it was originally called. Now it's called Transport Layer Security, or TLS. So it uses SSL/TLS to establish a secure connection to the web server. Then it uses HTTP to transfer that file within the encrypted tunnel. And a big component of the security along with HTTPS is the certificates that the server has. Essentially, the server gets a certificate that's signed by a trusted certificate authority. That means basically, hey, if you went to www.richesthebest.com and you have a certificate that was signed by a trusted certificate authority, then if you trust the certificate authority, then that means you trust the website is who they say they are. A little bit more about certificates. We'll actually generate some certificates in the lab. The server certificate contains the server's public key. For public key, private key cryptography, those are two mathematically related keys. Anything the client encrypts with the public key, the server will be the only one that can decrypt it, because in theory the server is the only one that has the private key. So the client sends something to the server that's encrypted with the public key. If the server can decrypt it, then that means the server is the entity represented by the certificate, and then that's how the client establishes the trust of the server by using the server's public key to encrypt something. And the actual thing that gets encrypted when you get down to the bottom of it is a session key that is then used to secure the communication. So if you think about that a minute, we have two different types of encryption: public key cryptography and private key cryptography. Private key cryptography is faster because you can use shorter keys. But the problem with that is, how do we securely exchange the key? Well, in this case, we securely exchange the key by encrypting that key with the public key of the server. Then the server can decrypt that key with its private key, and then we can use that session key to actually secure the communications. I talked a minute ago about certificates being signed by a certificate authority. I put trusted in double quotes, and we'll talk about that in a minute. A trusted entity that signs certificates. So if I want to have a web server that does secure web traffic on the internet, then the best case, I need to go get my certificate signed by a certificate authority. And then basically that builds upon a transitive trust model. You trust the certificate authority, the CA trusts the server, and then that means you trust the server since you trust the certificate authority, which sounds good, but who decides what certificate authorities you trust? Have you gone in and modified your browser certificate authorities list to cut out the ones you don't trust? Probably not. Basically, the browser maker decides which certificate authorities you trust, and we're going to look at that in the lab to see how many people you actually trust every day without really knowing that you trust them. So, summary of what we talked about: the web client asks for web pages from a web server. Web pages can be static, dynamic, or active. A URL contains a protocol, host, port, and path. HTTP is the protocol used to exchange web pages. Request and response to the two message types we talked about. Requests have methods. Response have status codes. We also have header lines. HTTPS is the HTTP protocol over the SSL TLS protocols. Over a secure tunnel creating using the SSL TLS protocols. It uses certificates to authenticate the server to the client, and then certificate authorities are the key to the trust, which I said was a transitive trust model. We trust the server because we trust the certificate authority, and the certificate authority trusts the server. So that was it for the internet and the HTTP protocol and HTTPS. If you have any questions, post them to the discussion board. Bring them to class.